still with me? Okay, very good. My name is Will Wilder, and I am the founder and CEO of Wilder Systems. And our goal is to make cost-effective robots for aircraft factories. So I use Google Docs at home, and so if there's like bullet points, these are supposed to be bullets. It doesn't translate quite right, so sorry about that. We're going to go through problem, solution, business model, company roadmap, IP, and then the management team, which it grew yesterday, so get to that. Okay, so the problem today is that to build airplanes, you have to drill a lot of holes, and they drill a lot of those holes by hand. And so by a lot, I mean there are 7 million fasteners on a 737, and so you can imagine that's a lot of holes. And about 25% of those are drilled by hand. That means a guy with a pistol grip drill. And typically in a hole making operation, you will touch the hole by hand about 4 times, sometimes more. You'll pilot drill it, so that's drill with a small drill bit to get it located correctly. Then you'll upsize it to the final size. Then you'll ream it, and then you'll countersink it. So each time you touch it with a manual drill, you're liable to induce a defect, which can be very expensive. So there's a market snapshot for you. There's a lot of airplanes that need to be built right now. Between Boeing and Airbus, they've got a 12,000 airplane backlog, and there's 2 competitors that are coming online, Comac in China and Sukhoi is coming in. Actually, they got qualified to fly in North America pretty recently, last 2 months. So the Russians are here too. So they're making these 150-person commercial jets. And at the same time, there's, I forget the exact market size for the military aircraft, but that's a group that's being squeezed for profits right now pretty significantly because of sequestration and so on. The U.S. government, we're not buying as much airplanes. Okay, so this is a typical wing assembly jig. You can see here, this is the jig, and then in here that's an F-18 wing. So what they're going to do is they've located the spars and the ribs in the jig. So that means they put them in the right spots and then tack fasten them together. They're going to apply the wing skins. The wing skin will probably be indexed off the jig in some way. And then after that, they're going to go to town with a drill. So somebody's going to be standing there for about 15 hours drilling that thing by hand. And hopefully all the holes are in the right place at the right tolerances, because that thing goes 1,400 miles an hour. So the solution, there's a couple potential solutions, but my solution is a low-cost, easy-to-integrate robot. So on the right-hand side, you see what's called a semi-manual tool. That one's called an ADU from SETITech. It's a French company. It's a pneumatic tool, and the way you use it is you locate a hard jig on the outside of the aircraft structure that you want to drill, and then the nose piece of the ADU goes into a rigid bushing, and the operator will press, it's on the other side of it, but there's a go button, and it'll drill, ream, and countersink in one shot. So you save all the time from the manual drilling operation, which was the 4-step drilling process. Cuts it down to about a 4-second cycle in a 3/4 inch stack of aluminum. But the downside is that you still have a 1-to-1 correlation between operators to drills. So you still have pretty high exposure to labor. On the other end of the spectrum, you've got these large systems. This is an electro-impact machine made up in Seattle, weighs like 100 tons and runs on train tracks. So you can imagine that the cycle to integrate that is pretty long, and they're very expensive. So it doesn't scale well, and you have to put in a lot of capital to buy a system like that. But I mean, they're good for some things. That's the wing. That's to produce the wing skin of a 737. So in the right application, it's good, but in the wrong application, it's expensive. And so I'm proposing a system like this. So this is the jig that was that showed y'all earlier. Basically, the idea is we've got a robot, a gantry machine on casters that you move up to the existing jig in the existing factory, and then it'll kinematically index in some way, lock to the jig, detect what jig it's on, download the correct part program from a server, and then execute the part program. with very little operator intervention, automatically prompting the operator for correct tools and stuff like that. So that's a close-up of the concept drawing that I've done. So the benefits are you can reduce the process time, and one of the strong benefits, I've spent a lot of time integrating robots in aerospace factories. A big thing that you get beat up on is inducing downtime in the process flow. So if they have to shut the line down while you're integrating the robot, that's a big problem for a lot of people because they've got these production forecasts that are like they have a 2-year pre-forecast. Basically, they're going to produce like MSN, line number 35 on this day and 36 on this day, and they've got it really laid out for 2 years, and they think that they're going to hit that. And then let's see, so they're pretty quick to procure. Building a system like the one I described is fairly straightforward, and there are always going to be manual tasks, so the operator will be free to go do those tasks while the machine is drilling holes by itself. So I've got a revenue model with 3 main revenue streams. There's a capital purchase, which is the one-time purchase price of the robot. Then there's some commissioning and any accessories. Like you can integrate vacuum cleaners and so on to do chip extraction at the same time as you're drilling, saves you time on the other end. There's maintenance, so go out, change the oil. And then services like NC part programming and factory layout, that kind of thing. So that'd be an engineering services business in conjunction with the actual sale of the machine. So does that make sense to everyone? Talking kind of fast. Okay, so here's the company roadmap. So I founded this company last September after leaving another aerospace robotics company I was with for about 4.5 years. I am filing a provisional patent tomorrow. Finally edited it and all this kind of stuff with the lawyers I hired. And so that's a system level provisional to cover the robot as like a part program kind of server thing and a variety of other aspects of the system that come together to make it a pretty unique system. So I didn't really describe a lot of the secret sauce today, but in the future, if you guys care, we can get into it. I'm applying for an SBIR grant to support a certain aspect of the machine development. So that's due on June 16th. It's coming right up. And then in July, I anticipate getting an order from GCAN, which is a UK company. They make the A330 outer wing box, among other large structural components for Airbuses. And then, I don't know, some other stuff. But basically, in the next year, I plan to be doing a lot of technical development and then sales of systems plus services. That's the package. Okay, so this is the IP I was talking about. So it's currently week 22. I'm going to file the provisional tomorrow, like I mentioned. And then if this develops as I intend it to, I will file a series of utility patents for details regarding the end effector, which is the business end of a robot that performs the task, and then the server and some other stuff that's in the provisional. It's forthcoming. So that's me next to a robot I integrated at Airbus in France. I qualified this system. It was just a twinkle in a Frenchman's eye about 3 years ago, having a robot that would go around and orbitally drill A330 fuselages during fuselage body joint. And through a collaborative approach with the R&T group in Toulouse, we came up with this 2-rail machine that goes around, and it's currently drilling A330s every day of the week. Okay, sweet. So, any questions?
When did you leave Airbus?
I never worked for Airbus,
Okay.
but the last time I was at Airbus was in, say, July of last year.
Were you like a contractor?
Yeah, so I was working for another company, and we were contracted to supply equipment to Airbus.
When did you leave your other company?
Let's see, I want to say, I don't know, let's say August 2016.
So pretty recently.
Yeah, I left there and started this company almost immediately thereafter.
Okay. Well, I'll talk to you about it.
Yeah, with regards to non-competes, that's been dealt with.
Okay.
Yeah. Yes, sir.
This kind of single task robot within what must be a really large factory in all of these cases, is that generally how the robotics is brought in as opposed to some bigger plan or bigger attempt at automating? I mean, talk about Airbus or something like that.
Yeah.
There must be sort of a broader view of the industrial automation, the use of robots. Do you need to fit into some bigger plan like that, or can you pick one thing and come in to automate that or validate that?
Okay, yeah, that's a good question. So, in my experience with aerospace, basically each factory produces like one specific thing. So, for example, a factory that I found that would be particularly amenable to this solution is making both F-16 and F-15 wings. It's in Tel Aviv, and that's all they do. So, the idea with this robot is that you design it so that it's applicable. They build that structure in phases. So in one phase they'll tack it together, and then the next phase they'll put on the skin. And these are different jigs. And so the idea is that the robot is able to identify which jig it's on and follow the thing through the factory. So the robot is actually applicable to multiple stages of the production process. However, it's not like making cars, man. Like cars go on a pallet and they go through the factory, and there's robots at each station and they kind of do things. Like it's more like building ships. You have like modules that are built at different places around the world, and then they're finally integrated in one line. For Airbus, they've got a final assembly line where, like, literally they put the wings in these giant aircraft. The wings are all built in the UK, so they bring them in this like giant A330 based thing, and then slap them onto fuselages that were built up in Saint-Nazaire, France, and so on, and then they just fly out the door. So that's the only like linear line that you would see with like a main line with feeders that would be comparable to aircraft manufacturing. Otherwise, it's super inefficient. I mean, they've got so many crane lifts and like AGVs going everywhere. Like, there's so much scope for efficiency improvements in aerospace.
But so would you be the robotic automation solution for a factory, the whole factory that makes some narrow piece, but that factory you'd be the automation approach? Is that what you're saying?
What I'd like to be is the automation approach for a type of application. So for a class of manufacturing, without being small jigs that are currently staffed by people with power drills, I want to be the go-to solution for that automation. So if they decide that they've got a series of jigs with a series of guys that follow the assembly through the production, I want them to buy a robot. I want everyone on Earth to buy robots that wants to upgrade their current manual process that uses that type of jig. But there's a trend in aerospace that's been ongoing, and you know all about it, obviously. But sorry, no, right behind you.
Okay.
2 minutes.
Yeah. don't want to embarrass you there, man. No, like they've been trying to take the automotive approach of using like those six-axis arms, like a KUKA style thing, and one thing they've run into is positional accuracy problems. They're extremely repeatable, but the accuracy is low. And so when we're talking about positional accuracy, to hit the 6 sigma positional accuracy, the real value of what you need to spec is like plus or minus like 4 thou, which is about 1.5 sheets of like writing paper. So that's like the plus or minus that you have to hit with 6 sigma repeatability to meet the guy's spec. So, I mean, I don't know. I think in the future people have this idea where you'll have like a flow line where you'll have like pallets with a 737 wing going down the line and there's robots, and then maybe like a 747 wing will come in and robots will know what to do where and so on. But I don't know. I think with the incrementalist like vision of like constant improvement, not like radical improvement, I think this is a decent solution. So, yes, sir.
Well, I might have missed like a key point here, but I don't see the business model. You've got a systems integration business near as I can tell.
Yeah.
What is the business model that you're proposing?
So,
in consideration that almost everything on an aircraft is going to have to be very custom. Each section of an aircraft has custom interfaces. So, is your product the robot?
yes.
Is your product the jigs? Is it integrating each work cell in a factory?
So the product itself, for now, is the gantry style robot with a drilling end effector. And in conjunction with that piece of hardware, I intend to sell services, which is NC programming services, system integration services, IT services in some cases, like making the robot communicate with their SAP server, for example. That's something that I've done before. That's a value-added service.
So it's a systems integration business, and you provide
A custom robot.
hardware, which is a repeatable component.
Yeah, where I hope to drive like 50%, 60% margins on the robot and sell services, marking up hours kind of a thing. I don't know. Does that make sense? Yeah, that's probably going to be pushed back. Yes. So I need to add to the team, but I've got a CTO who's going to be helping me out with that, doing the design and validation. The first delivery, we can get into it. It's an R&D system, so it's to GCAN's R&D group. And so delivery here is kind of a loose term. They actually want me to do a lot of feeds and speeds testing here in Austin. So basically, it's a single axis router essentially, and so they want me to qualify speeds and feeds with a router bit. So do we want to go 22K or 24K by 6 or whatever? That's that delivery. Yes.
Sort of qualification process does an industrial robot for this type of application require? I mean, you talked about one test just now, but reliability or long term. You're going to install this thing, go away, and the robot doesn't go crazy and go crazy holes on you. So, what exactly do you have to qualify to have it work in the factory?
So typically, the qualification, you have to qualify the positional accuracy. When you're talking about hole drilling robots for aerospace, what you're talking about is positional accuracy, which is how often do you get it where you say it needs to go, the hole. And then you'll talk about, there's some parameters about the hole. So there's roundness, you'll have some a tolerance on the diameter of the hole, and then you'll have countersink depth repeatability. So do you know what countersink is? Like, yes, you drill a hole so that it's a flush fastener. So yeah, those are the primary ones, is positional accuracy, roundness, and then countersink depth is pretty
I was
big.
thinking of things like mean time between failures or downtime, that sort of thing.
Yes, you'll spec MTBF on things like actuators, and usually I'll pull that straight from the manufacturer. My goal with this machine is to integrate as many COTS components as possible. Do very, very limited development of my own linear actuators. I just want to buy something from Moog, or there are thousands of linear actuator suppliers, for example. Or when you're talking about there's different specs on longevity of spindles, for example. So like a drilling spindle or a routing spindle, there's like S1, S6, and that has to do with the duty cycle that you're allowed to put it through, essentially. And so basically, as an integrator, you buy things that are already spec'd, and then you hand that as part of the design package off to the customer and say, we're going to work with you in case something breaks to figure out why it broke, and then work with the ultimate vendor of that component, replace it, do something else. If we chose the wrong component, I've had to do this before. Say I chose a bearing that wasn't good enough, you just replace it. Yes?
More of a comment, not a question. We went through an NSF SBIR too. We had a nice timeline like that, and I still have, you'll see. But we didn't get it. And then my plan completely got pushed out till the next NSF SBIR. So just start thinking of plan B in case you don't get that 225K or something from it.
Oh yeah, for sure. I got a great letter from the NSF guy just a few minutes ago.
Cool.
Yeah. All right. Thanks, Will.
Thank you.